Right, so the whole point of today's main lesson is looking at ionic formulae and looking at how we can write them. So whenever electrons are transferred, and again, I'm going to highlight that word transferred, so that was the same as our previous lesson, from a metal to a non-metal, charged particles called ions are formed. Ions are like elements, but they have a charge. So some will be positively charged, others will be negatively charged. Now, some rules to note, because what we're going to do now is we're going to stick these two positive and negative charges together. Only positives will combine with negatives. So this rule of opposites attract exists, if you like. Positives don't want to combine with positives. Secondly, and I'll highlight it in a different color, positive ion is always written first. Now the positive ion is always going to be a metal. So it is always going to be a case of metal and then non-metal. So metal, then non-metal.
Wait, if it's positive, it's a metal.
If it's positive, it's a metal. If it's negative, it is a non-metal. So it's always going to be metal, non-metal.
Wait, so like calcium would be like a metal.
Correct. Calcium is a metal, so calcium will always come first. Next, the overall charge, okay? The charge of the compound is always 0. And this means that we need equal numbers of positive and negative charges. Okay? And our final rule, and then I'll get to the question, is that polyatomic ions. So these is a very scary way of saying compounds. Okay? Compounds with a charge are written in brackets when we need more than one. And I'll show you some examples of this in a minute. Question up the back.
So if metals are positive, then hydrogen.
We group hydrogen in with everything else, so we can assume that hydrogen acts in a similar way to a metal. Yeah, hydrogen's often going to go at the start. There's only one, it's not a metal. But for all intents and purposes in year 10, we lie to you a little bit, just assume it goes first. All right? So, to help, let's go through these ones together, okay? So, number 1, we're going to start with sodium fluoride. So, I'm going to highlight all of my metals in yellow and all of my non-metals in green. So, metals will always be positive, non-metals will always be negative. So to start out, I know that the metal must come first, so I'm going to highlight sodium in yellow. A sodium ion is written as the symbol for sodium, Na, and we can use our periodic table to find that the charge for sodium is +1, written up the top right-hand corner. The next part is fluoride. So fluoride is the ionic version or the ion version of fluorine. So when we look for fluorine, we can see that fluorine has the symbol of F, and because it is in group 7, it is going to have a charge of -1. Now, in great news for us, if I have +1 and I have -1, do they cancel each other out? Do they equal 0? Yeah. Yes, and so what we can do is we start by writing the metal, Na, and then immediately afterwards we write capital F. We stick the two together. Our next example is silver iodide. So silver, is that a metal? Yes. So I highlight my metal in yellow again. I highlight iodide in green. So my metal, silver, is Ag+. Iodide is the ion version of iodine, and iodine has the symbol of capital I. The charge is 1-. So when I add these two together, plus and minus cancel each other out, so I can just write it as AgI. Now I'm going to skip down very, very quickly, and we are going to look at we are going to look at silver oxide. So silver oxide is this one here that I'm beginning to highlight now, so silver and oxide. So the reason I picked this one, we have silver once more, so Ag+, and I also have oxide. Now oxide is the ion version of oxygen. And I write O for oxygen, but the charge is 2 minus. And here becomes the first trick. If I now have 1 positive to 2 negatives, if I stick these two together right now, will it be balanced? No. So what do I need to do? I need to double the number of silver so that I then have 2 plus 2, 2 negative. And what this looks like for us is I start again by writing out AG. But this time next to AG, I put a little 2. And the 2 goes down the bottom right-hand corner. And it tells me that I have 2 lots of silver. Next to it, I can then write how many oxygens I'm going to have. And the answer here is O, just 1. So what does this actually look like? And I'll get to the question in 1 second. If I go off to the right here, if I have 1 silver plus and I have an O2 minus, okay, my 1 plus from here is going to move over there and it's going to turn it into O minus. I'm still short 1 electron, right? And so what happens is I need 1 more silver. And my second silver rocks up and it gives that electron over to oxygen. And so now everything has gotten rid of its charge. It's all balanced. And so all I'm writing here when I write Ag2 is I'm saying that I need 2 lots of silver to every 1 oxygen. Question?
Is the metal always written first and then the non-metal, or can it switch?
No, it will always be metal, then non-metal. The metal's name, again, always stays the same. The only thing that changes with the non-metal and the name is that "ide" at the end. So what I'm going to get you to do now, can you have a go at filling in the rest of these? And then we'll go through them together as a class.